Hey guys, it's Mr. Walker here again, and today we're going to be talking about subtraction, okay? We're going to be using some of the stuff that we learned in previous lessons as far as place value and everything like that goes, as well as what a tape diagram is and how to write problems vertically and all that kind of stuff. We're going to use all that knowledge to apply it to subtraction and really kind of dive into subtraction and how it works and how we can regroup and do different things like that to solve a subtraction problem. Now, the first thing I'm going to say is if you heard me say the term tape diagram and you're not sure what that is, to review it with you really quickly, what a tape diagram is when you use two different like rectangles and shapes like that to represent different numbers, and then you also think overall about like what you're trying to solve, and that becomes your variable, right? So we've used tape diagrams with addition, but we haven't used them with subtraction yet. So we're going to see what that looks like with subtraction. But again, it's another very helpful way of kind of diagramming the problem and laying it out so you can find exactly what you need to find. Now, along with that, I will say that we're going to be learning a couple different strategies, and we're eventually going to get to the standard algorithm that you can use to subtract, which is great. But if you're already familiar with those, you can totally use that strategy or any other strategy you know to solve these problems as long as you're doing it correctly. We're also just looking at like different ways that we could do it. And with the place value, to me, it really kind of shows like the behind the scenes again, the why of why subtraction works that way, why we can use the standard algorithm, what's actually happening to make that work. So we're going to be going through a couple of examples today, so make sure you have your place value chart to start. Make sure you have something to write on and that your brain's working in good shape and ready to go. And then we'll go ahead and get started with an example. So once you have your chart and everything like that, click continue and we'll keep going. Okay, so here's the first example that I have here that we're going to subtract. So I have 4,259 and I'm going to be subtracting 2,171 from that. So 4,259 minus 2,171. Now the tape diagram for this is going to look just a little bit different because we're subtracting from a whole. So we already know what the whole part is, right? So if I was going to draw my tape diagram, I would have the rectangles here representing my numbers, right? But my whole number up here, instead of using the variable, well, I know what it is already. I know the whole number is 4,259. So that's the whole. And I'm going to be subtracting this piece of it, which is 2,171. So what I want to find out is what's this piece? What's going to be left over? So this is what I'm actually going to be labeling as my variable, okay? I know what the whole piece is, I know what the whole tape diagram piece is, and I know what the part is that I'm taking away from that, so I want to know what's going to be left over. That's my variable, that's what I'm looking to find out. So again, this helps me to visualize it a little bit to see what I'm going to be doing, right? I'm essentially going to be, from this whole piece right here, I'm going to be taking away this piece. I'm only worried about this guy. This helps me to visualize it. I have to set it up a little bit differently in addition because I already know what I'm starting with. I know what I'm going to take away. I want to find out what's going to be left over, okay? So that's how I would set up my tape diagram to help me visualize this. The next thing that I want you guys to do is I want you to visually represent 4,259 in the place value chart. We're not going to do 2,171 in the place value chart. Any idea why that might be? I'm only going to be worried about 4,259 representing that here. Why is that? Okay, well, we don't have to worry about modeling this number because we only want to worry about the whole number, what we're starting with, and we're going to take everything else away from that. So we need to model that first number and then cross out the parts that we're going to be taking away. So we don't have to worry about this guy, we just model the top number. So I'm going to start by modeling my 4,000, my 200s, 59. Cool, so I have my whole number, 4,259, modeled here on my place value chart. So the next thing you want to do when you're subtracting is you want to look at your problem and make sure that you can subtract, okay? Make sure that everything's set up well, set up the right way, and then we can subtract these numbers. So if I start over here on the left, because again, we're going to go left to right, can I take 1 away from 9? So if I have 9 ones, can I take 1 away? Yeah, 9's the greater number, so we're good there. What about 5 and 7? If I have 5 10s, can I take 7 away from there? No, I don't have enough, right? So here I know already I'm going to have to do some regrouping. I'm going to have to move some things around in order to make this problem happen, right? In order to take 7 away from 5. Well, it's a good thing that we've learned everything that we have about place value so far, because I know that I can do something to help out my 5 tens that are sitting over here, right? I can take one of these hundreds right here, and I can unbundle them. I could take it apart and break it into 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Because 10 tens equal 100. So I'm taking this 100 here, I'm bringing it back to my tens, and I'm breaking it into 10 tens. Okay, so now I have a total of 15 tens. So can I subtract 7 from 15? Of course I can, right? I have plenty now. So if I needed to take 7 away, I could do that. 1, 2, 3, 4, 5, 6, 7. Which would leave me with 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I regrouped, I unbundled that 100 into 10 tens, and then I could subtract from there. Let's take a look at what that looks like over here vertically. So what that means is I had 200s, but what I had to do is I had to borrow one from there. So now I only have 100. But this guy, I didn't have 5 tens anymore. Once I unbundled it, added in those 10 tens, then I had 15 of them, right? And then I crossed out my 7. I subtracted my 7, which gave me 8. And now I can keep moving on, keep moving through my problem. So I have 1. Can I take 1 away from 1? So I have 100 left. Can I take it away? Sure. So that would leave me with 0, so I don't have any hundreds left. And now I have 4 thousands. I want to take 2 thousands away from that. Yeah, I can totally do that, which would leave me with 2. And I realized I never wrote down my ones when I did it, so I have 9, and I'm taking away just 1, which would leave me with 8. So now the answer to my problem over here is 2088. I had to do some regrouping with those hundreds, but it all worked out okay because I had enough to be able to unbundle and do that. Moving back down here to my tape diagram, what that means now is that A is no longer going to be A. I have the answer of 2088, which means if I added up my 2171 and my 2088, I should get the answer of 4259, because I now know the two parts of the tape diagram, which equals my whole, which I had from the start. So that's good to go there. All right, so that's a quick overview on how to regroup, like we had to do with our hundreds. I had to take this 100 and break it apart into 10 tens, right? No matter what place value I'm going back from, it's always going to break into 10 of that. So if I had to borrow 1,000, it would break into 10 hundreds. If I had to borrow 10,000, it would break into 10,000s, okay, so on and so forth. We know that from the work that we've done with place value so far. So knowing that makes it easier for us to subtract because we can borrow and get what we need. So let's take a look at another example and kind of practice this a little more and take it to another level. All right, I got another example up here ready to go. So again, take a second to a learning guide, to a partner, to somebody in your house. Read those two numbers together. Read them out loud so you can understand what we're trying to do here and what numbers that we're actually working with. And then we'll get going on the rest of it. Okay, so we have 23,422, and we are subtracting 11,510 from that. So what we want to do is, first I'm going to represent that with a tape diagram, right? And I already know what my whole number is, right? And that's that 23,422. Okay, and I know I'm going to be taking away part of it, which I'm going to represent here by my 11,510. I don't know what this other piece is going to be, so I'm going to represent this piece with just an A, because that's what we're going to be looking to find, right? If I start with this whole and I take this piece away, how much is left over? So that's how I can visually represent, using a tape diagram, that problem of 23,422 minus 11,510. So that's what I'm working with, right? I'm going to visually represent this in the place value chart. So I want you guys to go ahead and draw that in. We're just going to represent the whole. We're not worried about the part that we're taking away. We want to represent the whole first of 2,422. So draw that into your place value chart, and then we'll compare. Okay, so I have my 20 3,422 drawn in here in my place value chart, and I'm going to be subtracting 11,510 from that. So I want to start looking across and seeing where I can subtract and where I might be running into some trouble, and I might need to regroup or unbundle from another number. So starting off here, can I take 0 away from 2? Sure, not a problem. I have 2 here. I'm not going to take anything away from it, so it's going to stay at 2. All right, so that guy's good. My next one, if I move over, I have 2 10s. I'm going to take 1 away from that. Can I do that? Sure. Cross that guy out. I have 1 10 left over, so I'm going to have 1 10 left over here. Next, I move on to my hundreds. I want to subtract 5 from 4. Can I do that? No, I can't quite do that. So I'm going to have to unbundle one of my thousands and bring it into my hundreds place. So if I was going to do that, take a second now. What's that going to look like? How am I going to unbundle 1,000? How many hundreds am I going to have once I unbundle 1,000 into hundreds? Okay, so let's say I'm going to take this 1,000 here. I'm going to unbundle it into hundreds. So I would get 10 hundreds from that. 10 hundreds, right? Because 10 hundreds is the same as 1,000. So 1,000 would unbundle into 10 hundreds. So now I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hundreds, right? 14 hundreds. I no longer have 4. Now I have 14. Along those same lines, I don't have 3,000s anymore, right? Because I took this 1,000 and unbundled it and put it over here. So I don't have 3,000s anymore. Now I just have 2. But because I did that, I can now subtract, right? Can I subtract 5 from 14? Can I take 5 away from these 1400s? Sure. 1, 2, 3, 4, 5, which would leave me with 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would have 9 left there. I'm going to put a 9 over here. Perfect. 2. Can I take away 1 from 2? I sure can, which would just leave me with 1. And again, can I take 1 from 2? Yes, I can, which would leave me with 1. So my leftover, what I'd be left with here, would be 11,912. That would be my missing piece in my subtraction problem here, my missing piece in my tape diagram. So hopefully this is starting to make sense to you guys, starting to click a little bit. You can see how using place value helps us to understand why the standard algorithm over here works and how we can cross out numbers and move things over, unbundle numbers, right? That's what we're kind of doing in the background that we don't normally see. What we're going to do is we're going to practice this one more problem together. It's going to be a word problem, so that tape diagram is going to come in really handy for that. And we're going to forego, or we're going to skip this part of it and just use the standard algorithm to help us out. Follow along with me as we do one more example together and we try all of these things out. All right, guys, so far in this lesson, we've looked at how we can use tape diagrams to model what subtraction looks like, right? We've used the place value chart to represent the different numbers that we're subtracting and how we can unbundle those numbers and basically regroup and change some things around. And we also use the standard algorithm to subtract and label the numbers that we were regrouping and unbundling and things like that. We're going to take all of those things that we've learned so far and we're going to apply them to some problem solving with subtraction, okay? With this, I think the tape diagram really comes in handy because it helps me to visualize what it is that the problem is asking me to do. It helps me map it out so I know exactly what it is that I'm subtracting and why I'm subtracting it. So let's go ahead and read the problem together, and then we'll get to work using some of the strategies that we've used to solve this problem. So this problem says the paper mill produced 73,658 boxes of paper. That's a lot of paper. 8,052 boxes have been sold, so they want to know how many boxes remain, okay? So we have this word problem here. It's not a bad idea ever when you come across a word problem to read it twice. Sometimes you'll see you jump to a conclusion, you read that problem again, you go, oh, okay, hang on, wait a second, I need to do something else. So I'm going to read it one more time. The paper mill produced 73,658 boxes of paper. 8,052 boxes have been sold. How many boxes remain? The next thing I like to do after reading a problem twice is I like to highlight what is it actually asking me. What's the actual question, right? So they want to know how many boxes remain. So that's what we're going to be looking for. So from here, I would jump into the tape diagram part of things and kind of draw it out so I know exactly what it is I need to do, and I could see how can I find the answer to the question that they're actually asking me. So again, like we've done previously, I know my whole number, right? I know all of the boxes that I had, which was this 73,658. So I know that's going to be my total, right? That's what I'm starting with. So I'm going to write that up here, 73,658. Cool. I also have part of that whole as being 8,052. So this box right here, this rectangle, is going to represent my 8,052. What I don't know, what I'm looking to find out, is this other rectangle that's going to make up my whole, and that's going to be the number of boxes that remain. So I don't know what that is yet. That's why I'm going to be subtracting. So I'm just going to label that as a B for now, because I know that's what I'm trying to figure out, right? How many boxes remain? I put a B for boxes. It makes sense, right? All right, so now I'm going to set up my subtraction problem, and I'm going to use the standard algorithm to solve it. So I'm going to go with 73,658, because that's the whole number. That's what I'm subtracting from. And then I'm going to subtract from that the 8,052. Now, a couple important things I want to point out real quick is that I lined up my place value, right? I didn't write the 8 over here because I don't have 80,000, I have 8,000. So make sure that you always line up your place values. That way you know you're subtracting the right place value from the right place value. We don't want to get all messed up in there, right? This time I'm not drawing out my place value chart with my dots and my discs and things like that. I'm just going to do the standard algorithm, okay? So what I want to do now that I have this problem set up is I want to go from right to left and make sure that I could subtract each of these numbers, okay? I don't just want to go willy-nilly and just start subtracting. I want to make sure that I can actually subtract these numbers. So looking here first on the right, I have 8, and I'm going to take 2 away from that. So if I have 8 of something, can I give somebody 2? Sure. So 2 subtracted from 8 is going to give us 6. So that guy's good to go. If I move down to my tens place, I have 5 tens minus 5 tens. I can do that as well, and that will leave me with, that'll leave me with 0 tens. I took all 5 of them away. Moving down one more place value to my hundreds place, I have 6 hundreds, and I'm minusing 0 hundreds. I'm taking 0 hundreds away. So 6 take away 0, it's going to give me 6, right? I'm not taking anything away, so I'm good there. Moving on to here to my thousands place, I have 3,000 and 8,000. Can I take 8 away from 3? If I only have 3 of something, can I give you 8? No, so I'm going to have to do some unbundling and some regrouping here, renaming my numbers a bit. So out here I have 7 10,000s, and I know that there are 10,000s in one 10,000. I know that sounds kind of tricky, but you'll get what I'm going to do in a second here. So I'm going to take one of these 10,000s. So now I'm only going to have 6 10,000s, and I'm going to take that 10,000 and turn it into 10,000s, okay? So I'm going to be adding 10 to this 3 right here, which will make this 3 a 13. So I no longer have 3,000, I now have 13,000s, okay? Now that I have 13,000s, I can take 8 away from that, which would give me 5. And then I have my 6 10,000s out here, minus 0 will give me 6. So my answer is going to be 65,606, which means that's how many boxes are left over. So my leftover boxes is now 65,606. And I know what my missing value is here, which is also the answer to my problem, how many boxes remain. Okay, so what we just did here was use the standard algorithm to help us to subtract numbers. I also used a tape diagram to help me kind of lay that out so I could visually represent what it is that the problem was asking me to do. Whatever strategy that we've learned, whether it's using the place value discs in combination with the tape diagram and the standard algorithm, whatever works for you, I'm totally fine with you using it. We're just looking at the different ways to get the answer that we're looking for. So as long as you're getting the right answer, I'm fine with it. I just want to make sure that you understand kind of the why behind why we're doing what we're doing in here. So hopefully this helps get you guys on the right track. Please, as always, let me know if you have any questions, comments, or concerns. I'm more than happy to help. You can reach out to help from me, from another teacher, from your learning guide, from whoever. Just make sure you self-advocate if there is something that you need, and don't just put your head down and keep going. We're here to help you, okay? So thanks for watching, guys, and we'll talk to you soon.